All right, another day of computer science. Today the lecture was on, the big picture name was like variables and numeric types. So with variables, we've got the assignment statements read from left to right. The numeric types, we've got integer and floating point numbers. We learned some term called like mixed type expression. If it's a mixed type expression, it gets converted into a default into float. Identifiers are another name for names. That's something I when I saw on the board, I'm like, what are identifiers again? I totally forgot. It's just names. PEP 8, Python enhancement proposal 8. That's basically it describes the philosophy of why Python is created and written the way it is. What else do we have? Right, numbers or names / identifiers can only begin with or can only contain underscores, letters, and digits. So that's actually a problem I missed. I knew that, but in one of the problems we had to choose like the valid names, and I accidentally chose one that had a special character, like an apostrophe in it. So special character is not allowed in variable names or identifiers in general. Reserved keywords, there's only 35 reserved keywords apparently, and so the core language of Python only has 35 words, which is pretty low. It's actually crazy. There's only 35, but then there's built-in functions such as like print. So yeah. And then what else do we have? Identifiers, variables, assignment. There's something else in there with the assignment, but interestingly, we learned about three-step swap of two variables. If you have if you want to swap, say you have a value A and you have a value B, and you want to swap them, there's 3 steps. The first thing, you assign one of them to temporary value, then you swap the two, or you set one equal to the other, and then you reassign the one that was lost to the temporary value. Okay, anything else? Immutability, mutability. Numeric types are immutable, meaning you cannot change them in the same location. They get overwritten into a new location, and that has to do with the ID, the identification. Different than the identifier. The identification, the ID, is the location in memory where the object is stored. We talked about the object, value, type, and ID, and maybe name if it's a name-bound object. All right, I think that's basically everything. Let me go ahead and check formatting outputs. We didn't talk about formatting output. No, we didn't, but that's going to be formatting the floating point, which I guess we'll have to get to next lecture. Name, binding, memory, object properties. Oh, assignment statements. So there's this new way of looking at it. It's always going to be L value equals R value, where L value is an identifier or a variable. That is, I guess if it's an assignment, it's a variable. And R value is going to be some kind of expression. Read from right to left. So you read the variables from right to left, or the assignment statements from right to left. Mixed mode expression, not mixed type. All right, so that's everything for today. I will talk to you guys later today when I'm back studying some new stuff. So that's it for lecture for right now. What is up, guys? It is computer science. I'm back. All right, what did we learn about yesterday? Something about, that's right. I think compound operations, some P8, PEP8, some syntax, um, mixed mode expressions. That was today. I had it, I lost it. Where is it? PEP8, compound operations, floor division, and modulo. So that's basically the big thing. Modulo is just going to find the remainder. Floor division's going to... Does floor division return in a float no matter what? I think so. Yes, I think so. And floor division... No. Probably an int, no? I'm not exactly sure on that one. But floor division, what it does is divide, and then it rounds down to the closest integer, or rounds down to the next integer. So what I'm going to do is jump into Canvas, just read any announcements. Actually, it's Monday. This stuff's due to... My stuff for textbooks due tomorrow, so I'm just going to make sure there's nothing to do. He was supposed to post an announcement with the questions we didn't get to today, so I would like to see that and just make sure I get the right answers for the next questions. But he keeps saying he's going to release a GitHub announcement, but I haven't seen it, so... Alright. I'm just going to jump back into textbook right now, so I'll be back to recall what I learned today. Alright, so today we got into a new section, 5.4, known as the math module. So a module is a program in a different file. It's something along the lines of it's in a different file. It seems that it's going to have these functions that you can import and then call. So you import the module and then you can call these functions that are within the module. And for the math module, it's a lot of complex calculations, operations. Rather than basic arithmetic, you can do things like square root, exponential. Oh, I guess you can do exponents. But other things like trigonometry, and you can get the pi constant, the e constant value, etc. Ceiling is one function we used already, and it can be called by saying import math in a line and then using ceil, but you can also do apparently math.ceil, and then within the function, which is known as the argument, that the within the parentheses, the items that are called are known as, known as arguments. We learned about function calling, which is just basically I don't know how to say it besides saying calling the function. You're using the function. A function is essentially a list of statements that can be executed just by imposing its name or calling its name. Right. We can also do floor, which rounds down. I think that's most of it. Python code located in another file. Pretty close. Can be imported to your file. Square root, function, a list of statements that can be executed simply by referring to the function's name. Function call, invoking the function, argument, item that is passed, or items that are passed to the function. So that's it for today. I will talk to you tomorrow. See ya.